So elementary signals are basic signals, okay? So using these signals will build the complex signals or complex functions. So we'll discuss about some of the important elementary signals. So first one is exponential signal. So x of t is given to be e power at. Okay, this is an exponential signal. So how do we tell it's exponentially increasing or exponentially decreasing? Okay, so e power at is an exponentially increasing signal. It's exponentially increasing signal or increasing function for a greater than 0. Okay, and it's exponentially decreasing function for a less than 0. For a less than 0. Fine. So exponential signal represent as e power at. It's an increasing signal, exponentially increasing signal for a greater than 0. Okay, and it's exponentially decreasing signal for a less than 0. So it's graphically represented like this, e power at. For a greater than 0, it looks something like this. Okay, and e power minus at. So exponentially decreasing signal, if we say a less than 0, a is negative. Okay, so it will be something like this. It's 1 and it will become 0 at infinity. Okay, so this is case 1 and this is case 2. In exponential, you have two types. If a is greater than 0, it represents the exponential growth. Okay, if a is less than 0, it will represent the exponential decay. Fine, this is about exponential signal. Next, we shall see unit impulse function. Unit impulse signal or unit impulse function. It is also called as delta signal or delta function or direct delta function. Okay, so you people have seen what is a unit impulse signal. If x of t is a unit impulse signal, it will exist and represent as delta t only. So it will exist only at t is equal to 0 with amplitude 1. Okay, it is 0 for all other values of t. So we have seen this, right? So how do we define delta t or impulse function? It is 1 for t is equal to 0. That means it will exist only at t0. And it is 0 for all other values of t. It is 0 if t is not equal to 0. Okay. So what does this 1 represent? We just tell unit impulse signal means the area is 1. Area of this unit impulse signal is 1. Okay, but we say amplitude is 1. So that's not exactly amplitude, but it implies the area of the unit impulse function is 1. Okay. This is about unit impulse signal. That means area of the unit impulse signal is 1. Usually impulse signal will look like this. Delta t. So this is a unit impulse signal. So usually an impulse signal will be infinity at t is equal to 0 and it will be 0 for t not equal to 0. Usually impulse signal means it's infinity at t is equal to 0 and it is 0 for all other values of t. But unit impulse means we say area of this unit impulse is 1 or amplitude is 1. Okay. When t is equal to 0, this is 0 and this is t. This delta t rises to infinity. Okay. For all other values of t, it is equal to 0. Clear, everyone? Following? So as I told you, we have seen this in previous semester also. I told you why we have to take it as infinity, or why we call the area of this as 1. So we get unit impulse signal from rectangular signal. Okay. Suppose you have a rectangular signal. I'll take it as some y of t. Okay. And this exists from just a numerical. I'll take minus a to a. And the amplitude of this is half times a. Okay. So this is time axis. So I'll tell y of t is a signal which is, the amplitude is half a from minus a less than t less greater than a. Okay. So between minus a to plus a, the amplitude is half times a. Okay. It is 0 otherwise. So this is a rectangular function. So if you integrate this, we have to find the area of this. So what is the area of this? So minus a to a y of t into dt. So this signal we have to find the area. So what is the area of this? Length into breadth, right? So what is the length? It is 2 times a, and breadth is half a. So 2a into half a. So you get 1. So we tell area of the unit impulse function is 1. So how do we get unit impulse? So what happens is, in this rectangular function, this minus a tends to 0 and this plus c also tends to 0. So if these tends to 0, this signal will go upwards. Okay, so that area will be 1 for unit impulse function. So this is the condition for unit impulse function. So you have, if you have minus a to a signal existing from minus a to a with amplitude half times a, then if this signal tends to 0, minus a will come near 0, and even 0 and plus c also comes to 0. That time what happens to the area? It will grow upwards towards the top. Okay. So that time the area will be 1. So for unit impulse, the area of the unit impulse is 1. For normal unit impulse, for normal signal at t is equal to 0, the signal tends to infinity. But how do we get this impulse function? We get unit impulse function from rectangular function only. So if minus a will tend to 0 and plus c also tends to 0, you have a signal only at t is equal to 0. So it will be, the area will be equal to 1. If you calculated area when these minus a and plus a tends to 0, that would be 1. Okay. So we have seen the area. This area is 1, right? So if this minus a tends to 0 and plus c also tends to 0, this signal it will just exist at t is equal to 0. Okay. That area, if that area of that signal would be 1. Okay. Imagine you have minus a and plus a here. If that tends to 0, you will have a signal only at 0, and area of that unit impulse is 1. Clear, everyone? Unit impulse signal. So you have to know about what is an impulse signal and what is a unit impulse signal. Okay. So that is why I have shown you the difference. And coming next, we have unit step signal. I'm explaining you these in terms of continuous time signals. Okay, discrete time I'll just brief up at the end. It will be the same, just in x of n domain. So coming to unit step, you know what is a unit step signal, right? It's represented as u of t. So u of t, definition of unit step signal will look like this. U of t. So it is 0, sorry, amplitude is 1 from t is equal to 0 up to t is equal to infinity. So this is your unit step signal. It is 0 for t less than 0. So we shall see the definition. U of t is 1 for t greater than or equal to 0. It is 0 for t less than 0. This is a unit step signal. Okay. So we have seen what is a power of unit step signal, right? So what is the power of unit step signal? Power of u of t. It's a power signal, okay? So what is the power of unit step? Could anyone tell me what is the power of unit step signal?
Ma'am, a square by 2, so for here it will be 1 by 2.
Yeah, it's half watt. Okay. So power of unit step is half watt. What is energy of unit step? Energy of unit step signal, it will be infinity. Okay. So we have to note few things. So if you differentiate unit step, you get unit impulse. Okay. You have to know this for solving problems. If they tell you to differentiate, then you have to do the differentiation function. Okay. So differentiation of unit step gives you impulse signal, unit impulse. So d by dt of u of t gives you delta t, that is unit impulse. Fine. So, and if you integrate unit impulse, you get unit step. Integration of unit impulse gives you unit step signal. So if you have a unit impulse signal, if you be integrating, then you get unit step signal. Okay, so integration of delta t into dt will give you u of t. You have to know these things. Okay, these are important. So if you differentiate a unit step, you get unit impulse. Conversely, if you integrate a unit impulse, you get unit step signal. Okay, so next we shall see about ramp signal. What is a ramp signal? Unit ramp signal. We represent it as R of t. Ramp signal or unit ramp. Better you can take it as ramp signal. So ramp signal is given as R of t. It is t for t greater than or equal to 0. It is 0 for t less than 0. So how do we represent a ramp signal R of t? So at t is equal to 0, it is equal to t. At t is equal to 0, t will be at 0 only. At t is equal to 1, amplitude will be 1. At t is equal to 2, the amplitude will be 2. At t is equal to 3, the amplitude will be 3. At 4, it's 4. It goes on up to infinity. Okay? Clear? Clear everyone? Ramp signal. Unit ramp signal means the slope will be equal to 1. Okay? Is it clear everyone? So if you differentiate a unit ramp, you get unit step. Okay? So make note of that. Differentiating a unit ramp, so d by dt of r of t, if you differentiate a ramp signal, you get a unit step signal u of t. Okay, if you integrate a unit step signal, you get ramp signal. Okay, what is amplitude of unit step? It is 1. If you be adding 1, 1, 1, you get a ramp signal. Okay, so and if you differentiate a ramp, you get unit step. So we have a discussion that if unit ramp is even or odd signal, okay, it's neither even or nor signal, nor odd signal. Okay, unit ramp is neither even nor odd signal. Even unit step also. Okay. So that is about unit ramp. Is it a power signal or energy signal, unit ramp? So we can say unit ramp is neither energy nor power signal. Okay, so if you can go on to calculate the power, for this you get infinity. Even energy for this is also infinity. So it's neither energy nor power signal. Fine. So now we shall see rectangular signal. So these are the basics for you. Okay. So operations of signals will be doing on unit step, unit ramp, unit impulse. Okay. Different operations will be doing. So coming to unit rectangular function, or just rectangular function, you represent it as rect of t, rectangular function. Okay. So it's also called as rectangular pulse, or you also call it gate function, rectangular signal. Okay. So definition of rect of t is nothing but, so if this is your diagram of rectangular function, rect of t, so it will exist from minus just a minute, whiteboard is hanging. It's called rectangular pulse or gate function, right? So it's graphically represented like this. Rect t exists from minus a by 2 to plus a by 2. This is 1 by a. Okay, or you can take minus t by 2 to plus t by 2 and amplitude as 1 by t. Anything, this is just a representation. Okay, a. So rect of t is equal to 0 for t less than minus a by 2. Okay, it is 1 by a between minus a by 2 to plus a by 2, and it is 0 for t greater than a by 2. Okay, where a is a real number. So rectangular function is 0 for t less than a by 2. Okay, it is 0 for t greater than a by 2, and it's 1 by a, amplitude is 1 by a between minus a by 2 to plus a by 2. Okay. Now what is the area for this? Area of this rectangular function? Length into breadth. Okay, so what is the length? A by 2 plus a by 2. So it is a, and height is 1 by a. So length is a and height is 1 by a. So you get a into 1 by a, it is 1. So it's unit rectangular function. Okay, the area will be equal to 1. That is length into breadth or base into height, you get it as 1. Is rectangular signal even signal or odd signal? Could anyone tell me? It is even or odd signal rectangular function?
Even, ma'am.
Yeah, because rect of minus t is equal to rect of t. Okay, So it is a even signal. So if you have a signal rectangular minus a by 2 to a by 2 with amplitude 1 by a, if you time reverse that, that is if you multiply time with minus t, so this is rect of minus t and this is rect of t. So that would be the same. Okay, it is symmetric about y-axis or vertical axis. So it is minus a by 2 to a by 2 and with amplitude 1 by a. So it's an even signal. Its energy or power signal, rectangular function is even signal. Its energy or power signal,
Power signal, ma'am.
why power signal? Is it repeating itself at equal intervals of time?
Sorry, ma'am, it's energy non-periodic signal.
Yeah, by definition, they're telling you it's 1 by a amplitude from minus a by 2 to plus a by 2. If t less than minus a by 2, it is 0. For t greater than plus a by 2 is also it's 0. So it's energy signal. What is the energy of rectangular function? It is an energy signal. What is the energy? Could you calculate and tell me what is the energy of this signal? Minus infinity to infinity, a modulus of x of t square into dt. So it is existing from minus a by 2 to plus a by 2 with amplitude 1 by a. Right? So you get, solve and tell me what you get. So 1 by a square, I take it outside because it's a constant. If you integrate with respect to 1, so you get t from minus a by 2 to plus a by 2. So you get 1 by a square. Yeah, you get 1 by a. So a by 2 minus of minus a by 2. So you get 1 by a square into a. So you get 1 by a. Okay, this is the energy of rectangular function. 1 by a joules. Next we shall see triangular function or unit triangular function. It is represented as tri of t. Okay, so this is tri of t. It exists from minus 1 to plus 1 with an amplitude 1. Okay, this is time axis. So by definition, tri of t is equal to t plus 1 between minus 1 and 0, and it is minus t plus 1 between 0 and 1. Okay, clear everyone? It is t plus 1, the equation is called t plus 1 between minus 1 to 0, minus 1 and 0. It is minus of t plus 1 from 0 to 1. So what is the area of this unit triangular function?
Ma'am, can you explain how did you take that minus t plus 1, ma'am?
Yeah, I'll explain you. First you take down the area. What is the area of this? I'll tell you how we got t plus 1 and minus t plus 1. So what is the area of this unit triangular function? Half into base into height. So what is base? It is 1 plus 1. It is 2, right? So base is 2, half into 2 into 1. So area is 1 unit. So it's even or odd signal?
Even, ma'am.
It's even signal. And it's energy or power signal?
Energy, ma'am.
It's an energy signal. Okay. because it's non-periodic and we get finite energy. Okay, so I'll tell you how we got the t plus 1, the equation. And we'll calculate the energy of this. Okay, so you have a signal like this. It is x of t, okay, and it's present from minus t to plus t, okay, with some amplitude a. So how do we write the equation of this signal is x of t is equal to a times 1 minus modulus of t divided by fundamental period of that. Okay, so I'll take first, I'll explain this signal for you. X of t, I'll take like this from 0, 1 and 2, okay, with amplitude 1. So it will consist of two ramps, right? This is one ramp and this is one ramp. This is positive ramp and this is negative. Positive means or increasing ramp and decreasing ramp. Okay. So 0 to 1, it is positive ramp, and 1 to 2, it is negative ramp. So how do we represent ramp signal R of t? It is t for t greater than or equal to 0. It is 0 for t less than 0. We know that this is a definition of unit ramp signal, right? Or ramp, just ramp signal. Yes.
Ma'am, 0 to 1 negative and then 1 to 2 positive.
Yeah, just it is increasing ramp and decreasing ramp, or positive slope and negative slope, you say, right? Like that.
Okay, so 0 to 1 will be the negative.
Positive slope. You get slope positive,
Sorry,
right?
positive. Yeah, positive
This is negative,
slope, and
negative
1 to
slope.
2 is negative slope.
Yeah. So, oh, sorry, 1 minute. So if I have a signal xa of t, I have a signal xa of t, so from 0 to 1. So how do we represent a ramp signal? We represent it as t, right? So this, I'll take it as xa of t. So this is from 0 up to 1. Okay. So what is the equation for this? T, right? It is t.
Yes, ma'am, T, ma'am.
Equation
Because
for
of the positive slope.
Yeah, the equation for this signal is just t. Okay. So what if I shift it? So I'll shift this signal here. What do you get? What is the equation for this now? At 2, let it start at 2. So what is the equation for this?
T plus 1.
T plus 2.
T plus 2 or t minus 2?
Ma'am, but it is rising, right? It's a positive slope, right? So it will be T plus 2, I guess.
Don't worry about slope. So if this equation is t, this is starting at 2. This slope is starting from 2.
2T, ma'am.
No, it is t minus 2. Okay, so we shall see about operations of signals. That time you will get more idea about it. It's just like unit step signal. So this is u of t. So if it starts from 2, what is the equation for this?
T minus 2.
U of t minus 2. So if it starts from minus 2, what is the equation for this?
U of t plus 2.
U of t plus 2. This is similar concept. Okay.
Okay,
this
so
is,
ma'am,
Ma'am,
yes.
ma'am, so basically we have to assume that the waveform starts from 0.0, no ma'am?
Yes. That I've
Okay.
shifted right. If you have right shifting, you have t minus 2. If you have left shifting, we'll have t plus 2. Okay, I'll
Ma'am,
explain you.
basically we are seeing here for the different values of t, right? Like for t is equal to 1, 2, like that.
No. Shifting, we are just seeing. I'm telling you how to write an equation for this signal. I'm telling
oh,
you how
ma'am,
to
if
write
it is on
equation
the
for. Yeah, I will tell you. So this is t minus 2. So if starts from minus 2, what is the equation for this?
t plus 2.
T plus 2, correct? So now we'll go back to our signal. So this is our signal. We were trying to find. Oh, this is our signal which we are trying to find the equation for this. So what is the equation for this? Try to imagine from 0 to 1 the equation is t. Okay, from 1 to 2 what is the equation? So this is a signal x of t. Okay, it is 0, 1, 2. So this is our x of t. So from 0 to 1 we got the equation. It is t. Okay, from t is equal to 0 to t is equal to 1. The equation of signal is t. So at 1 to 2, from 1 to 2, what will you write that? So first,
Minus t, ma'am.
yeah, x a of t will be, this is t. Okay, suppose I want to write from 1 to 2. So I'll assume my signal is starting from 2. So what will be the equation for this? It is t minus 2, right? Because at t is equal to 2, it is starting. If you equate t is equal to 2, the signal will start from 2. So if I time reverse this signal, what do I get? This, I'll take it as xb of t. This is xa of t, this is xb of t. So I'll take xb of minus t. So what is the equation for this? T minus 2. What is the equation for this? It is time reversed. So what is the equation we get? This is t. Just t should be negative, that's all. From this is t minus 2. The signal is starting from 2. But we want from here to here, from 1 to 2, right? So what is this equation?
Minus t plus 2, ma'am.
Yeah, it's 2 minus t or minus t plus 2. Got it?
Ma'am, what if it's on the other side, ma'am?
Which side?
Like on the minus 2 side, then it will be minus 2 minus t.
No, first did you understand this one?
Yes, ma'am. This I
This you
understood. So
followed, no? Yeah, wait. That we'll discuss when we solve problems. Okay, if I tell everything, that also you'll get confused. First we shall see, just I'm explaining you energy of the signal. So to take energy, how to know what is the equation, right? So understood, you have to take t for this, and what is the equation for this? 2 minus t. Clear?
yes, ma'am.
Clear, right? So
Yes, ma'am.
Yes, ma'am.
So I'll tell you one minute. I'll tell you how to write the equation for this. So how do you write equation for this? So A is amplitude, okay, and you have 1 minus t by fundamental period. Okay, so what is the equation for this signal, which we have seen for this signal. What is the equation for this signal? It is t between 0 to 1 and it is 2 minus t between 1 to 2. Correct? Shall I write in equation form here? So you have a signal from here to here. It is 1, 2. This is your x of t. So how do you write x of t? It is t between 0 to 1 and it is 2 minus t between 1 to 2. Understood? Did you guys
Yes, ma'am.
follow?
Yes, ma'am.
So how do you calculate energy of this? It's an energy signal, right? Triangular wave is an energy signal. So how do you calculate energy for this? So what is the equation for energy? E is equal to minus infinity to infinity modulus of x of t square into dt. Fine. So from 0 to 1, what is the equation? It is t square into dt, and from 1 to plus 1, from 1 to 0, what is the equation? It is 2 minus t whole square into dt. Now calculate the energy of this
It's
triangular
1
wave.
to 2, ma'am.
Yeah, 1 to 2.
Ma'am, it's 1 to 2.
Yeah, it's 1 to 2. So what is the energy of this signal? Try to find out. So if you integrate t square, what do you get? T cube by 3 with limits 0 to 1 plus from 1 to 2 this is of a minus b whole square form, right? So you get a square plus b square minus 2ab into dt. So this is t cube by 3 with limit 0 to 1 plus 1. Integration limits 1 to 2. You have 4 plus, this is t square. 4 plus t square minus 4t into dt. Now try to integrate this. So if you put limits for this, it will be 1 by 3 plus, you get 4t plus t cube by 3 minus 4t square by 2 with limits 1 to 2. So substitute the upper limit and lower limit and tell me how much you get.
Can you scroll a little bit up?
Yeah. One minute.
Ma'am, little bit down. Yes. Yes, ma'am, enough.
Yeah.
Ma'am, energy is minus 19 by 3, ma'am.
No. Check once. So 1 by 3 you have plus I'll put upper limit now. So what is the upper limit? So 4 into 2 I get 8 plus 2 cube by 3, that's 8 by 3 minus 4 into, I'll cancel this 1 and 2. So minus 2 into 4 I get t square, 2 square. Okay. minus, I'll get 4 t into 1, t is 1, 4 into 1 plus t cube by 3 is 1 by 3 minus 2 into 1 square, I get 2. So solve this. So you get 1 by 3 plus 8 plus 8 by 3 minus 8. I'll put small bracket here.
Ma'am, is it minus 4 by 3 joules?
No. Check once. Not 4 by 3. Not minus 4 by 3. Yeah, it will be minus, okay. Minus 8 plus 8 by 3 minus 8 minus you get 4 plus 1 by 3 minus 2. Okay, so it's 1 by 3 plus, so what you get? Minus 8 plus 8 will get cancelled. So you have,
Minus 2 by 3, ma'am.
it's 2 by 3 joules.
Okay, ma'am.
So 1 by 3, so here you are left with 8 by 3 and here you get 2. Okay, if you multiply with the 2 with negative, you get minus 2 minus 1 by 3. Okay, and now I'll take it in one equation. 8 by 3 minus 2 and 4. You get plus 2. So that if you multiply that with negative sign, you get minus 2 minus 1 by 3. Correct? So if you have 1 by 3 plus, take LCM, 8 minus 6 minus 1. So 8 minus 7 you get 1. So it's 1 by 3 plus 1 by 3, which is nothing but 2 by 3 joules. Clear everyone?
Yes, ma'am.
Got it? I'll just brief up once. So I have just explained you from 0 to 2, a signal from 0 to 2. So what if it's other side? So if the signal starts from 0, the equation for that is t. If it starts from minus 1, what is the equation for that?
T plus 1.
Yes, so I have written this as t plus 1 between minus 1 to 0 and it is minus of t plus 1 from 0 to 1. Got it everyone? If my ramp signal starts from this, it's r of t, it is equal to t. So if it starts from minus 1, it is t plus 1. If it starts from 1, it is t minus 1. Got it everyone? This much you understand. Okay, next we'll see operations of signals. Okay, after this. So you'll have better idea when we see operations of signals. Clear everyone? You want me to repeat anything?
Yes, ma'am.
Clear? So triangular function is represented as tri of t. It is t plus 1 from minus 1 to 0. The equation is equal to t plus 1. And it is the equation from 0 to 1 is minus t plus 1. Okay? So the area of this is 1. So it's unit triangular function. It's an even signal. And it's non-periodic and it's called energy signal. So we calculate energy of that signal. Okay? So we get energy as 2 by 3 joules. Is it clear, guys? Following? Following or not?
Yes, ma'am.
So regarding operations, I'll discuss about these operations, okay, how we get shifting and all, to how we get 2 minus t and all. So I hope you have understood this, but I'll discuss when operations of signal when I discuss, I'll tell you once again, okay, how do we take that. This is it clear everyone? How do we get energy of this triangular waveform? So 0 to 1, we take equation as t, and from 1 to 2, it is 2 minus t. Okay. So because this is t minus 2, reflection of that is 2 minus t. Okay. So 2 minus t is of the form a minus b whole square. So expand that and integrate, and upper limit minus lower limit, you get 2 by 3 joules. Okay. And we have two more elementary functions. We shall see that. So the next one is signum function. It is represented as SGN of t. Okay, so the signum function we represent like this: SGN of t. It is 1 for t greater than 0, and it is -1 for t less than 0. At t is equal to 0, it is 0. It is +1. This is -1. This is time axis. So you have to know about this function, okay, signum function. So in your higher semesters, you will be using this. So in elementary signals, you have just introduction for signum function, okay. So signum of t is equal to -1 for t less than 0. It is 0 for t equal to 0, and it is 1 for t greater than 0. Clear?
Yes, ma'am.
So this is a definition of this signal. So just know this signal. It is a signum function. It's 1 for t greater than 0. It is -1 for t less than 0. And at 0, it is equal to 0. So next you have sinc function. Sinc function. It is represented as sinc of t. SINC of t. So we represent sinc function like this. Sinc of t is equal to 1 at t is equal to 0. It is sine pi t by pi t for t not equal to 0. Okay, so we represent that like this graphically. So you have a signal. Let me draw properly. So here. It is also called as cardinal sine. Cardinal sine function. So graphically it will look like this. Okay, this is a sinc function. So at t is equal to 0, its amplitude will be 1. And for other values of for other values other than 0, it will be sine pi t by pi t. It is 1 at t is equal to 0, and this is minus t2 plus 2. Got it? This is called sinc function. Clear, everyone?
Yes, ma'am.
Elementary signals. So these two are special signals, okay? Signum and sync. Just you have to know what are those. Okay, in higher semesters you'll use these. So we have seen till now with respect to continuous time. With respect to discrete time, I'll just show you. Ma'am is taking your next class.
Yes, ma'am. She'll take, ma'am.
Okay. So unit step. Okay, you just see. Just 5 minutes I'll take. So u of n is equal to 1 for n greater than or equal to 0. It is 0 for n less than 0. So at 1 is equal to 1, 2, 3, 4, so on up to infinity, amplitude will be 1. Okay. So unit impulse, we represent it as delta n. It's present only at n is equal to 0. Okay, with amplitude 1. So delta n is equal to 1 at n is equal to 0. It is 0 for other values of n. And ramp you represent as r of n. R of n is equal to n. Okay, it is equal to n for n greater than or equal to 0. It is equal to 0 for n less than 0. So this is a ramp signal. R of n. At 0 it will be 0. At 1 it will be 1. 2. At n is equal to 2 it will be 2. At 3 the amplitude will be 3. At 4 the amplitude will be 4. It goes on. Okay. And the signum function will be Sg of n will be equal to 1 for n greater than 0. It will be 0 for n is equal to 0 and minus 1 for n less than 0. Amplitude values. So is it clear, everyone? So signum would look like this. For n greater than 0 it is 1, and for n less than 0 it will be minus 1. Minus 1 plus 1. This is signum of n. Okay, it will go on up to minus infinity. This goes on up to infinity. Got it? Understood, everyone? Elementary signals. Followed?
Yes, ma'am.
Okay, guys, then we can wind up this class. If you have written your name and USN in the chat box.
Ma'am, can we leave, ma'am? Ma'am is waiting for
Sure,
us.
sure, you can leave.
Yes, ma'am. Thank you, ma'am.